Hello students, welcome to video lesson 4.6. This is going to be our last video in chapter 4. Your book does continue with some other things, but this is where we're going to end our work with chapter 4. We're going to talk about angles in polygons. Okay, this is sort of an extension of what we've been talking about so far in chapter 4, most of which has been about quadrilaterals or four-sided polygons. Today's lesson is going to broaden that out to any number of sides for a polygon, okay? A five-sided polygon or 6 or 7 or 8 or as many as we want, okay? And specifically, we're going to talk about the angles in polygons, okay? Interior angles and exterior angles. We will talk about both of those in this video. We're going to start with the discussion of the interior angles of a polygon, okay? And interior angles just basically mean the angles inside a polygon, okay, the inside ones. So, for example, in this five-sided shape here, which of course is a pentagon, I have 5 interior angles. Okay, one of them is here, 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 and the other one is here. Okay, so there are always the same number of interior angles as there are sides of the shape. So a five-sided shape has 5 interior angles, a six-sided shape has 6, and so on, okay? What we're going to first concern ourselves with is the sum, or meaning the total when we add together all the interior angles of a polygon. Okay, there's an interesting rule that we can follow to find the sum total of the interior angles of any polygon. And it's based on the number of sides. So what I'm going to do is I'm going to let n, lowercase n, be the number of sides. Okay, n for number of sides. And I'm going to sort of show you where this little formula comes from, and then I'll tell you what that formula is to allow us to find, like I said, the sum total of all the interior angles. So in this case, it would be, these 5 angle measures all added up together. Okay, and this basically just comes from the idea that the sum of the interior angles when we had a triangle is 180 degrees. Right? The sum total of the angles in a triangle are 180 degrees. So what I can do is I can take this five-sided shape and I can actually divide it into a number of triangles, okay? And to do that, I just simply pick one corner and I try to draw as many diagonals as I can. So I'm going to start at the top and I'm going to draw a diagonal down to this bottom right corner. And then I'm going to draw one also from here down to this bottom left corner. And I think that's the only diagonals that I can draw, right? Because the rest from this corner to here would be a side of the shape, and from this corner to here's a side of the shape. So I can only do 2 in this case. So I draw 2 diagonals, and I want you to notice that what I've done to my five-sided shape, to my pentagon, I've basically divided the five-sided shape, or the pentagon, into 1, 2, 3 different triangles, right? I have this triangle on this side, I have the one going down the middle, and then I have this one over on that side. So I've divided the five-sided shape into 3 triangles, okay? So five-sided shape got divided into 3 triangles, and each of those triangles is supposed to have a sum total for its angles of 180 degrees, right? So for the five-sided shape total, those 3 triangles put together, the sum is simply 3 times 180 degrees for each triangle, which is equal to 540 degrees. Okay, 540 degrees. So the sum of the interior angles for a five-sided shape is always 540 degrees, no matter what, okay? Because you can always do this diagonal drawing and divide it into 3 separate triangles, okay? Let me show you another example here. Here I have a 6-sided shape. This 6-sided shape has 6 interior angles, and I want to find the sum total of all of those interior angles. Okay, I want to sum together this angle, this angle, this angle, this angle, this angle, this angle, those 6 angles added together. I'm going to do the same thing I did before. I'm going to take one corner, and I'm going to draw diagonals from one corner to as many other corners as I can. In this case, I'm going to start over here on the left-hand side, and I'm going to draw this diagonal up to here. I'm going to draw from that same corner this diagonal over to here. I'm going to take this diagonal and draw it down to here, and I think that's going to be it for the diagonals that I can draw in this case. So I want you to notice what I've done with this six-sided shape now. I have divided it into 1, 2, 3, 4 different triangles. So the six-sided shape turned into 4 triangles. Okay, 4 triangles, and so the sum total of the interior angles for the six-sided shape is simply 4 triangles multiplied by 180 degrees for each triangle, which leaves me with 720 degrees, okay? So the sum total of the interior angles in a six-sided shape, also known as a hexagon, is always 720 degrees. That's the sum total, okay? Now I have one more example for you, and then maybe we can pick up on the pattern that we're seeing here, okay? Here I have an 8-sided shape, an octagon, and I'm gonna one more time do my diagonal drawing to divide this shape into a bunch of triangles. This time I'm gonna have to draw a bunch of diagonals. I think 1, 2, 3, 4, 5 diagonals. And that divides this shape into 1, 2, 3, 4, 5, 6 different triangles. Okay, so an 8-sided shape got cut into 6 triangles. And so the sum total is 6 times 180 for each triangle, which is going to be equal to, I believe, 1,080 degrees. So that's the sum total of all 8 interior angles. So, you know, one at this corner, one at this corner, one at this corner, one at this corner, and so on all the way around the shape. These 8 angles all added together equal 1,080 degrees, okay, no matter what, because it's an 8-sided shape and I can always divide it into 6 triangles. Now, if we go back through and look at this, I want you to try to figure out the pattern between how many sides the shape had and how many triangles I could then create, okay? So remember, when I had a 5-sided shape, that turned into 3 triangles when I drew my diagonals. When I had a 6-sided shape, that turned into 4 triangles when I drew my diagonals. And when I had an 8-sided shape, that turned into 6 triangles. So the pattern here, what we should notice, is the number of sides minus 2 is how many triangles we can create by drawing diagonals from the same corner. Okay, the number of sides minus 2. And then the number of triangles that we made, remember, we multiplied by 180 degrees because 180 degrees is the sum total in each triangle. And then we multiply that by how many triangles we made. That's the sum total for the bigger shape. Okay, so what we end up with is this formula here. We have the sum of the interior angles, the inside angles in any polygon, based on the number of sides, which I will call n, is simply this. It's n minus 2 times 180 degrees. Okay, that's the sum total of all the interior angles of a polygon. Now, for example, if I were to have, let's say, a 14-sided polygon. It's not one that I can really draw very well for you, but let's just imagine that we had a polygon that had 14 sides, okay? There would then be 14 interior angles, and the sum total of those 14 interior angles is, well, we can follow our formula, right? If I wanted to know what is the sum of the interior angles, it would be n minus 2, but remember, n is the number of sides, and I just told you this is a 14-sided shape, times 180, okay? So that's 12 times 180, which is going to be 2,160, I believe. You can check my math on that. I just did that in my head real fast, but I think that's what it is. 1,800 plus 360 would be, yeah, 2,160. So 2,160 degrees if I were to add up the total measure of all 14 angles in a 14-sided shape. Okay. Another thing this allows me to do is imagine that I have a shape, and I don't know how many sides it has, but I know that when I add all the inside angles together, I know that they add up to be 900 degrees. Okay, it's 900 degrees. The question is, how many sides then does that shape have? Well, if we think about this number, this 900 as my sum, that is supposed to be equal to n minus 2 in parentheses times 180, right? And now we should think algebra skills, right? Can we solve this equation for n? Can we figure out what n is equal to? Well, the answer is yes, because I can simply undo the multiply by 180, right? This says multiply, sorry, it looks like a minus. Multiply by 180, so I can undo that first, and then I'll just have n minus 2 left over. So if I divide away 180, and I divide this side by 180, 900 divided by 180 is 5. So 5 is equal to whatever n minus 2 is, because I did 5 times 180 to get 900. Then to get the n by itself, I just plus the 2, and I get 7. So this shape must have 7 sides. Whoopsies. Okay? Must have 7 sides. So we can always find the number of sides given the measure, the total measure of the interior angles, because we can just undo our formula, or we can figure out the sum total of the interior angles if we know how many sides the polygon has. Okay? Now, there's a specific type of polygon, and actually all of these have been those, but I haven't marked it as such. There's something called a regular polygon, which we need to sort of understand, because that allows us to do a little bit more with these interior angles. Okay? A regular polygon is simply a polygon, a shape, where all the sides are the same length and all the angles are the same measurement. Okay? So as I said, the shapes that I had created up there were regular polygons. So here's an example for you. This is a regular pentagon. And then I know that each of these angles here is exactly the same number of degrees. These 5 angles, same number of degrees. And also all 5 of these side lengths are all congruent to each other as well. Okay, so that's a regular pentagon. And if a polygon is regular, looking down here now, if a polygon is regular, we can find the measure of each individual interior angle because they're all supposed to be the same, right? So remember that the sum total of these 5 angles, right, the sum from up above, I believe was 540 degrees, right, 540 degrees. But each one is supposed to be equal, right, because it's a regular polygon, so all the angles are the same. So if I have 540 degrees and it's 5 angles that are all the same, I can divide that by 5, and I know that each angle measures 540 divided by 5 is 108 degrees. Okay? So we can find the measure of each individual angle by dividing the sum total by the number of sides. All right? So you may be asked to do that in your homework. Okay, to find each individual angle, and that's okay as long as they tell you that the polygon is regular. Now, as long as we're talking about regular polygons, this is going to lead me to something that's related to what we had been doing previously in chapter 4. We've been talking a lot about quadrilaterals or 4-sided shapes. If we think about a 4-sided shape, that would be regular. A regular shape, again, all the side lengths the same, all the angles congruent. Well, all the side lengths the same implies to me that it's a rhombus, right? And then all the angles the same, could we figure out maybe how much each one of those is supposed to be? If we have a regular 4-sided shape, what is the measure of each angle, right? So let's see. Let's just start by figuring out the sum total of the angles for a 4-sided shape. Again, that's going to follow our formula, n minus 2 times 180. And in this case, n, number of sides, is going to be 4. So 4 minus 2 times 180, well, that's 2, 4 minus 2 is 2, times 180 is going to leave me with 360 degrees. So a four-sided shape always has interior angles that add up to be 360 degrees. Now, if it's regular and all four of the angles have to be the same, I should be able to divide this by 4 and figure out each angle, right? So in a regular four-sided shape, each angle is 360 divided by 4 is 90 degrees. Okay, so each angle is 90 degrees. So think about what that means. I make a four-sided shape where all of the angles have to be 90 degrees. Well, this is a rectangle, right? And remember, because a regular shape has to have all four of the sides be congruent as well, this is a square. Okay, so moral of the story, a regular quadrilateral four-sided shape is a square because it has to have all the sides the same, which makes it a rhombus, and it has to have all the four angles be the same, which means each one is 90 degrees, which makes it a rectangle. And we know that if it's a rhombus and a rectangle, it has to be a square, right? Okay, so that's it for interior angles, okay? Except that we are going to use them to also talk about something called an exterior angle of a polygon, okay? Exterior angles of polygons are slightly more complicated than interior ones just in how they're made, but they are no more complicated in terms of the mathematics, all right? So here's the deal. An exterior angle of a polygon is an angle that is created by, let me move this a little bit, by extending one side of a polygon. We extend one side in one direction, okay? You can make two different exterior angles at each corner, but they're really the same thing, and so we only ever make one exterior angle at each corner, okay? So let me show you sort of what one looks like. The easiest one for me to do is down here. So if I start here and I just extend this side a little bit this direction, and then I take this and I'll put a little arrow on here. Okay, so I extend one of the sides. For example, in this case, I extended the bottom side of this. I think it's a seven-sided shape. I extended it this direction. Do you guys see the angle that I have created on the outside of the shape then? Right here is what we would call an exterior angle of this seven-sided shape. This is an exterior angle because it is created by extending one side in one direction. Okay, now I can continue to do this at each corner. So I can do it this way, and then I can do it this way. Generally, we sort of go the same direction around the shape. I can do it there. This one's going to look a little bit interesting, but I can do it there and go through my word angle. I can do it this way, and I can do it this way. Whoopsies. Let me get that back. And then I believe there's one more I can create. So if we can create one of these angles, one exterior angle at each corner, and we know that in this case, because there are 7 sides, there are 7 corners, I can create 7 exterior angles. So the number of exterior angles we can create, as long as we only do one at each corner, is the same as the number of sides, okay? So I have these 7 angles. And there's something really interesting about exterior angles of a shape. How big or small an exterior angle is depends sort of on how big or small the interior angles are, particularly of a regular polygon, right? We can find the measure of exterior angles in a regular polygon, similar to what we just talked about. And it depends on how big or small the interior angles are, all right? So here's the deal. An exterior angle is always equal to 180 degrees minus an interior angle. Okay, because the outside angle here and the inside angle here, they create a straight line, right? They create a 180 degree angle. Okay, so it's also true that an interior angle is equal to 180 minus an exterior angle. Okay, so they have this relationship. Interior angles and exterior angles at the same corner always add up to 180 degrees. Okay, so that means as the interior angles get bigger, the exterior angles get smaller, okay? But as the exterior angles get smaller, there's more of them because there's more sides on the shape. And so what we find is that actually the exterior angles of any shape ever, no matter how many sides it has, is equal to 360 degrees every time. Okay, so there's no formula for exterior angles. They're always equal to 360 degrees all the time added together. Okay, so these 7 angles here, this one, 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 these 7 angles on the outside would all add up to be 360 degrees. So now if the polygon is a regular polygon, right, if it's regular, then we can find the measure of each individual exterior angle by dividing that 360 by the number of sides. In the case of this 7-sided shape, 360 divided by 7 would equal the measure of the angle. It's approximately 51.42 degrees or so. 51.4 degrees about, all right? So we can find each individual exterior angle if we know that the shape is regular because it's 360 divided by the number of sides. The sum of all the exterior angles put together is always 360 degrees no matter what, okay? So that should be everything for this section. Interior angles, exterior angles, regular polygons. If you have any questions about any of those or formulas or rules or anything like that, please reach out to me. Otherwise, that's all I have for you right now, and we'll talk to you soon.